welcome to the industry panel. I am Joe Christie, and I am the Senior Manager for Metro Energy in Raleigh, the Southeastern office for our company. This panel is it's got a lot of energy integral into these guys, and you'll see it, feel it. It's sort of like when we come up here and work on our energy performance contract at Appalachian. We find out that there's a lot of energy, and it takes a lot of energy from our guys to actually even keep up with this campus. The campus moves very quickly. I mean, whether they're working on getting something done on the campus or getting their own stuff done, running, biking, hiking, it goes on, and then I go home and breathe. So we got the panel. Each panelist is gonna have about 10 minutes to go over some of the technologies. You've got some world-class companies here to go over some of the technologies that are new or engaging or forthcoming. So we'll let them proceed with all that. We've been here, Metro Energy's been here 5 years, working on first one project at $5.4 million worth of energy savings, and then just recently signed the $16.5 million project for future energy savings on the next phase. So let me introduce, right now, I'd like to introduce Gary Steinberg. And Gary is the System Manager, Outdoor SSL. I'll let him tell you what that is, fixtures for GE. And good thing about Gary, he didn't have to come very far. He lives in Henderson County. So it's, you know, we're worldwide. We're putting things into this campus. The campus feeds a lot to other people, but it's locally grown mostly. Gary has an MS in optical engineering from the University of Rochester, other degrees in physics and electrical engineering, 32 years of experience in electro-optical systems design. He is currently lighting, his major position now at GE is in lighting solutions as the systems manager. And he runs product performance specs, long-range technical planning. So he's the right guy to talk at this presentation today. Gary?
So I heard there were problems with this yesterday, mostly caused by the people creating presentations like us. So it happens to me today. It's my fault. Thanks for the opportunity to be here. I'm really enthused to have this opportunity to talk to you, and I'm pleased to see everybody's hung around for Friday's discussions. GE, you probably know the name, a very large business working in power generation, aircraft engines, water processing, oil and gas, appliances, and it probably touches you some way every day, either through the electricity you get or something you use. What you may not be real aware of is what GE does in the lighting segment. GE's been in the lighting business for over 100 years and supplying lighting systems since the 20s. And in the mid-50s, GE consolidated those businesses for the outdoor lighting business into operations in Hendersonville, North Carolina. That's the business that I work for. We do about 1 million plus fixtures a year in Hendersonville, and primarily produced for the outdoor lighting space. So stadium lighting, roadway lighting, area lighting, flood lighting, indoor industrial lighting was produced in that plant. And historically, this plant has been based on the creation of HID or legacy light source fixtures, but we're making a change. Why is lighting maybe important to everybody? Globally, lighting consumes about 19% of the world's electrical production, either through indoor commercial use, residential use, or industrial uses. So it's a large percentage of what we generate electricity for. It obviously consumes a lot of wattage, 3,000 terawatt hours a year based on current projections, and increasing annually as the world develops and adds more lighting. So it's on track to potentially double by 2030 if we don't do something to try and change the course of So that's the scope of what we're confronted with in trying to move the mark on lighting. And what's great about it, I'm really jazzed about being in the lighting business right now because there's a big technical change going on. A big technical change going on in the lighting industry, and that's the advent of solid state lighting being able to be used in general purpose lighting applications. Solid state lighting has been worked on for decades, and I would say maybe a little more than a decade ago was really starting to become effective with respect to penetrating specialty lighting applications like traffic signaling and other monochromatic applications where the efficacy of the LEDs that were available at that point in time could be put to use. It kind of then evolved into additional kinds of specialty lighting, for example, refrigerated display case lighting or other kinds of case lighting where localized lighting was sufficient, but it really didn't have the legs yet to go after general purpose lighting. In the last about 6 years, that's really changed. LED manufacturers, great as an example, have become very adept at creating LED light sources with efficacies that meet or exceed all the available legacy light sources that you could use for general purpose lighting. So the industry is experiencing a huge transition at this point in time, working to convert essentially every legacy lighting product into an LED variant of some sort. And this gives us the opportunity for immense cost savings from the standpoint of the money that we spend on providing lighting services. LED-based lighting is leveraging the basic efficacy improvements of the light sources with improved product designs to give us the opportunity to save anywhere from 20 to 80% of the energy used to deliver the lighting services that people need. So how are we doing that? Every fixture that we currently manufacture in a legacy format for HID product or incandescent product is currently being redesigned to operate based on using LED light sources. And there's a few key things that are happening in those products. One is the knowledge of thermal management and optical design is being applied more judiciously. And combining that with higher efficacy sources is delivering lighting fixtures themselves that are much higher application efficacy, if you will. We've learned how to put the light where we want it more directly, not waste it up, not waste it back. And with LED light sources, you can make design choices in your optical systems that improve the base optical efficiency and put the energy where you want it. That combined with increases in efficacy, anywhere from legacy efficacy for light sources will range anywhere from maybe 15 lumens per watt for a classic incandescent source to as high as about 135 lumens per watt for the most efficient high pressure sodium sources can now be replaced with LEDs that as kind of a base capability might be at least 90 lumens per watt, commercially broadly deployed at 130 lumens per watt in systems such as roadway products or area lighting products, and in the laboratory maybe running 150 to 200 lumens per watt. So the efficacy opportunity and the ability to put efficiency in the hands of lighting designers in the fixture products just keeps increasing. The other thing that's really happening in the lighting system business is moving from classical fixture approach to a systems approach by integrating controls and IT resources to leverage the information that you can get out of controls and sensors to make better use of the lighting energy, to deploy it for lighting purposes when only people are there, to reduce power consumption on dim lighting when it needs to be on but occupancy levels or the demand for lighting is lower. So every major lighting manufacturer is deploying control systems, sensor systems, occupancy sensing, daylight harvesting, and various other control technologies into lighting platforms. Right now, a lot of those are accessories, but over time, I think you'll see all these control methodologies move to higher levels of integration in the lighting products. And you're also seeing a big press on the IT and systems side to start doing data mining. There are examples where occupancy sensing basically being used to monitor building usage, feedback to the system owners, how best to utilize the space, avoiding infrastructure and capital costs in some instances for adding space. So the lighting systems and the lighting control systems are being used as data collection subsystems for the physical infrastructure of facilities. So that's really, I didn't want to dive deep into a lot of numbers and details, but I wanted to give you a top-level overview of where the industry is going. And there's lots of runway. Penetration of these technologies into the installed base is very small, and there's lots of opportunity to improve. But what it really means is that people have to start providing different kinds of capabilities and services in the lighting businesses. Technologists need to be different to facilitate solid-state lighting than they may be needed to be for classical legacy technologies. We need advanced optical engineering capabilities. We need improved electronics in the form of power supplies and drivers. We need engineering people that are experts in thermal management, because LEDs have to be treated differently than the classic radiated sources. And we need people with mechanical and combined mechanical and thermal expertise to learn how to dematerialize these systems and minimize the material use to provide the thermal and mechanical capabilities that we have to put in these products. Environmental needs and sustainability needs are increasing in the market. Most procurement specifications that are issued these days require that products be compliant with ROHS, possibly REACH requirements in Europe, and other sustainability metrics. Those are historically aspects of lighting systems that were essentially ignored, but are now becoming much more prominent aspects of what a lighting manufacturer needs to consider when designing and producing a product. And finally, I guess my order got messed up a little bit. Learning how to deal with incentives and finances is pretty important. We all know that money isn't any easier to get now than it ever has been, and maybe it's more constrained. We have to become creative about how we incentivize and develop financial opportunities for people to actually purchase and deploy these systems. And I think some of our other panelists will be talking about those aspects especially. But lighting systems manufacturers, especially a business like GE that has a financial portion of its business, are cognizant of these issues also, and work to create financial packages that make sense for buyers and systems owners also. So historically, we might have been mostly concerned about figuring out how to price it right and sell it. Now we have to be concerned about how to price it right, sell it, and coordinate financing for the buyers and system owners also. So it's a little more complicated. That's about all I had to say. That's a top-level view of how GE is involved in the lighting business. And question, I guess, we'll go for balancing panels.
Now we have Clay Nessler. Clay came in from Wisconsin, so that's I believe it's a worldwide headquarters for Johnson. And so Clay has got a long background like everyone here. He's Vice President for Global Energy and Sustainability with Johnson Controls, and responsible for sustainability strategy and policy and innovation, and runs the Johnson Controls Institute for Building Efficiency. He received a BS and MS in mechanical, and from the University of Illinois, Urbana-Champaign. And the interesting part is he's co-inventor on 10 patents. So we've got, if you have any questions, he's the one we're going to use first. But on questions, we're pretty good on time here. So we're going to be having, after everybody speaks, we'll jump on the questions. So be thinking of something, because that's the energy that comes out of this kind of panel.
company was founded by a university professor, Professor Warren Johnson, who invented the thermostat. The thermostat you see today is directly related to his invention. Over 125 years ago, he invented it because he got tired of rapping on the pipes. One rap when it was too hot, two raps when it was too cold would wake someone up in the basement, and that's how they adjusted the temperature back then. Today, Johnson Controls is a Fortune 100 company, and we have three main businesses. The business I'm representing is the building efficiency business, which makes building controls and HVAC equipment and services to improve the energy efficiency of buildings. We make automotive interior components, which like seats and interiors and things like that. We're also a battery manufacturer. We've been active in North Carolina since 1912, and we have about 1,000 employees here in the state of North Carolina, and we're very proud that 59 higher ed institutions are our active customers here in the state. So with that, I want to do something a little bit different. I certainly don't want to compete with my good friend Amory Lobbins on vision. I think that's pretty much impossible. But what I want to do is tell you a story, and this is a near future vision of a day in the life of a smart campus. How many of you have heard of Ray Bradbury? Okay, a lot of you, good. Unfortunately, Ray Bradbury passed away about a year ago, but wrote a number of great books, Fahrenheit 451. I'll let you think about what that number means. But he had one great quote that I'm going to use to start out my presentation, and that quote is, "The future is here today. It's just not evenly distributed." So let's take a look at a future with elements that are in place today all put together into a campus. Our story begins the evening before a day in the life of a smart campus, and this is a little key that will be below all my slides. What you see here is the energy use profile of a typical campus in its energy profile on a very hot, humid day where there's a very high peak. The white will show you the resulting energy profile due to various integrated intelligence of the systems in the building. And this is an important little curve here. This is the electric price. In order for all this magic to happen in the future, we're going to need to have price of electricity that changes on at least hourly, hopefully minute-by-minute basis that reflects the true cost of generating that electricity, as well as the environmental impacts. Let's begin our story. At 8 o'clock, the night before, we start making ice. This is an ice storage system. In order to reduce the peak energy demand, instead of running the chillers flat out on the hottest day of the year, we're going to melt ice for chilled water. The control system talks to the weather center. It's got a very detailed energy model of the campus, knows exactly how much ice to make it gets to work. About midnight, we plug in the electric vehicle fleet. In the near future, almost all of our vehicles on campus will be electric, plugged in at night. They're not just going to charge in when we plug it in. They're going to actually communicate to the grid, and they're going to charge their batteries when there's excess wind energy on the grid. Big problem today is there's excess wind, and we're producing it in the Midwest. We need it in the East, and we're producing it when we don't need it. We need to store that energy. We can store that energy with hydro or pumped compressed air, but a really smart way would be to connect all these electric vehicles together and charge them slowly over time when we have excess capacity. At 2 o'clock, we start cooling down the building. Yeah, it's actually not optimum to wait to the last minute to start cooling all the buildings and run the systems flat out. For buildings with lots of mass, like many of the buildings here on campus, it'd make a lot of sense to cool the building down to the bottom of the cooling range on a hot day and let that drift up over time. At 4 o'clock, the chiller, which is very smart at this point, detects the fault. There's a problem in a valve, and it's not going to be able to make ice. Well, that'll be a big problem next time, because the campus really relies on this ice to provide a good percentage of its cooling during the peak hours. So the chiller computes the cost of this fault. Very high cost that day, automatically dispatches a technician, which comes out with the right part at the right time to make the repair. By 7 o'clock, everything's fixed. The technician goes home, and an email goes out that says, "There was a problem, we fixed it, you're good to go." At 8 o'clock, the faculty and staff start pulling into the parking garage, and a lot of them are driving plug-in electric vehicles again. they plug in. Now, again, we're not gonna start charging those vehicles all at the same time, right? We don't want a big peak here. But we know we wanna charge them in the morning because the price of electricity is gonna be very high in the afternoon. We've got a very accurate estimate of that. But we also know the average commuting distance of each of the faculty. So the computer in the car knows how much charge is left in the battery. The HR system knows how far their average commute is. We had a couple miles, so they can pick up eggs and milk on the way home, and we charge them just enough to get them home without having to run the engine. At 9 o'clock, meetings start taking place. This is the Alumni Center. We got a bunch of business folks coming into a meeting. We know that that room is scheduled for 9 o'clock, so we don't start conditioning until they're in at 9 o'clock. We got carbon dioxide sensors in the room, so it's a very popular meeting. A lot of people show up. We can increase the ventilation. If it's like one of my staff meetings and almost no one comes, then we can crank down the air conditioning and the ventilation and save some energy. At 11 o'clock, the utility sends out a message that yes, in fact, the price of electricity is going up. We're starting to address some grid conditions, and we start taking actions. We let the temperatures float up by 2 degrees. We start dimming the lights very slowly. With these new solid-state lighting, you can reduce 1% output every couple minutes, and no one even notices it. You can get 20% easy. We also start melting the ice. At 1 o'clock, our sophisticated lighting controls come in place. We start dimming the lights because it's a bright sunny day, and the blinds move automatically. This is a picture from our headquarters in Milwaukee, Wisconsin. We're very unique in that we have 4 LEED Platinum buildings on one campus. It's the highest concentration of LEED Platinum buildings on one site in the world. And all of our blinds, which you see here, every 20 minutes they move. Our control system computes the position of the sun every hour of every day, and it knows exactly where the workstations are, so it drops the blinds so that you get no direct sunlight in any of the occupant spaces. It's sort of eerie. Every 20 minutes it just goes zoop, zoop. Now if it's cloudy, they all go up and you get maximum benefit of the daylight. At 2 o'clock, we need to reduce some more energy. Now we get the students and the faculty and the staff involved. Email blast goes out, tweets, this, that, the other thing. Social media kicks in. And it's really a simple measure. We ask everyone to unplug their laptops. You know, we talk about plug-in hybrid cars, but the ultimate plug-in hybrid is actually your laptop. If you take it out of the wall, you've got a couple hours, hopefully, of power to run your laptop. And you're not continuously trickle charging via battery. You can save an incredible amount of plug load just by doing those simple things. You can also take automated action in your data centers to stop doing backups and put the servers in sleeping mode so they use less energy for a period of time. This campus, much like ASU, has solar, has wind, actually has, in this case, has electrical storage as well. And the utility really likes a flat demand. In fact, will compensate the campus quite a bit for being able to shave off that peak. But every once in a while, when clouds come out, the output from the solar PV systems drop. So in this particular case, we're using large-scale electric storage to be able to buffer that. So the output of the combination of storage and PV is constant throughout the day. At 4 o'clock, the facility director wants to check in on the performance of their energy efficiency projects, just like the ones going on here at ASU. The neat thing about solar is you can measure the output of solar. The neat thing about the power coming into the campus, you can measure it. The hard thing about efficiency is measuring what didn't happen because you did something. And Amy Lovin's probably talked about megawatts at least once. And essentially now we have the technology to create a negawatt meter where we actually create a model, a sophisticated model of the campus. We can predict how much energy it would have used if we hadn't made the improvements. This is actual data from a community college in Chicago where they did a very large retrofit of about 22%. And then what you love to see is the energy continues to decrease 2 to 3% a year for the last 6 years. Technology exists today to put this virtually in every building on campus and track it over time. At 5 o'clock, some faculty are leaving the office. This guy forgot to turn off his lights and he left his lab on and his computers, but the security system knows that he badged out, and the surveillance system knows that that area of the building's empty and basically watches his back and turns off all the energy consuming things. At 8 o'clock, the facility director pulls out his iPad, looks at a map of campus. This happens to be a map of the world because this is the dashboard that we use to run our global organization. And just by clicking on any building, he can look at the status of open work orders, any alarms, energy use, carbon emissions, anything that person wants to see. Now that data will be available anywhere on the planet that facility director goes, but you know what? With this level of intelligence and automation, probably won't have to log in at all. Now, what I've shown you looks like far future, but every single thing I've shown you is either in operation today, in isolated instances, or is in pilot or in the labs. This is a near future scenario. What we need to do is take all these ideas, put them together, put them in place, hopefully here in the state of North Carolina. For more information on any of these things, you can visit our Institute for Building Efficiency, where we have a number of white papers in this general area. It's a great pleasure to be here today, and thank you very much.
Okay, we got it on time, we're good. Next speaker is going to be Chris Halpin. Chris Halpin is actually working on this campus now, as I guess everybody is. All of this panel happens to be coincidentally working on campus. We will be shortly. Chris is president of Celtic Energy, and he's tried to explain to me how to say that correctly several times. So it's I would say it's Celtic, but an independent energy consulting firm that he founded in around 2000. Celtic Energy assists clients in reducing energy costs locally, nationally, internationally. And that's interesting because he's been in the energy business 28 years, helping ESCOs as an owner's rep to watch the calcs and make sure things are correct for the owner and for the project as it goes through. He has lots of public clients, Department of Energy, all parts of the military, energy offices in North Carolina, Nevada, Rhode Island, Louisiana, and other states. Excuse me. He has a bachelor's degree in mechanical engineering and is a registered PE. And his PE is in 7 states. Now that's not too unusual, but he also has one in the Republic of Ireland. So that might be an interesting discussion at some point. So Chris, here you go.
It's tough bringing up an Irishman when you just said we're ahead of time. I'm saying hello in 10 minutes. What we do. I apologize for my voice. I was really enjoying our time here, both with some of my older friends at the university system and some of my newest best friends I met here over the past few days. And away we go. Education is extremely important to me personally and to our business. And I learned at this school a few years ago. Happens to be from an Irishman as well. And I think that really speaks to what we're here about this week, is that we're not here to fill these kids' heads with more details and data and regurgitating tests, but we really need to get everybody excited about this, the business, the learning experience, and apply those experiences in a way that's going to benefit everybody that's here, everybody you touch every day from here till the near future and far future. Hopefully we can post these slides because I will never get to all of these, I'll tell you right now. But I want to talk a little bit about us. We're slightly less well known than other esteemed panel members. A little bit about the market history and future, a little bit about student engagement, and finally something we call green resilience. And this idea, Amory talked a little bit about the other night. Chris Peach, who's here as our Director of Sustainability Services, was Amory's right-hand guy for 7 years, traveled the world with him. He's really brought a lot of that experience to our company, which we're very thankful for, and I want to thank him for his input on these slides. So he already said a little bit about this. We've done work for all kinds of people, from major corporations to universities, state energy offices, and so on. I was the global energy manager for NCR Corporation for 4 years, which gave me a really interesting background, having worked in the consulting engineering side and working for an owner. I really saw what goes on out there, sort of behind the curtain from the owner's perspective. And it really gave me another challenge in my career to try to make all these like wonderful technologies we're talking about today, make sure they get installed, make sure they get commissioned, and make sure they actually get operated and maintained properly over time. And unless you have the right market signals in place, it's very difficult to do that. So that's one of the reasons I started my company after working for an ESCO for 4 years. I wanted to make sure that the owners and the ESCOs all got treated fairly, and the campuses ended up with really high quality projects. And it's been a really fun experience, and that's some great people. It's really the best thing in all of this. And we've done work for over half the campuses here in the U.S. and in North Carolina. And we have locations across the country. We've done work for the military, GSA, and stuff all over the country. It's been very, very interesting experiences. We've worked with virtually all the major ESCOs out there, as well as these days solar and microgrid developers, just something we'll talk about in a few minutes. Now, some of the things I've seen in the history of this business, again, I've been at this since 1985. I don't feel quite as much like the crazy guy on the mountain anymore as I used to. You see people on planes and you tell them what you do, and they're all very interesting to go back to the book. Where now people are asking me about those curved light bulbs, and hey, I have a problem with my furnace and so on. So it's great to see that. We've seen a lot of things go on in this business where there's great applications, great technology, great systems, great ideas. There often wasn't a way to get them paid for and applied. Okay? And that's really been a detriment to this business over time. One of the reasons was market signals, a 2 to 3 year payback term requirement, a little silly from, especially on a university campus setting where most of the universities that represent here have been here 100 years or more. We want to look at things in a more long-term place. What we've seen is a real pent-up demand for energy efficiency investment over time. One of the reasons is because those market signals were not there. That's one of the things you see that are really changing now. And really just in the past 5 years, it was very timely for many respects with the economic meltdown we went through, because things were really starting to gel by 2007, 2008. And a lot of that demand would have been because water it wasn't. So what we really see now is financing mechanisms. Alternative financing has really come into its own. Much like the LED lighting and other technologies and controls really come into their own now. There's a confluence of all these things that are allowing folks like you and your partners in the industry to get a lot of good work done in a short period of time in a very high quality delivery mechanism. A few of the things that I've seen, again, we could spend 20 minutes on each of these, but we've already spoken a little bit about energy savings performance contracting, and that's our primary role here in North Carolina, is sort of keeping an eye on these for the university campuses and others. This is the game changer in this business, is property assessed clean energy. We're the technical due diligence folks for the state of Connecticut and their program. It's the first one. It's a statewide PACE program that allows building owners, in this case it's aimed at the commercial retrofit market and industry, to invest in their buildings, and the investment stays with the building. So like many commercial real estate folks, they flip a building in 2 or 3 years. So they don't want to spend money on that, especially for that silly lighting and control stuff. They don't really understand it for the most part. It allows them to invest that money. It gets treated as a tax assessment through their local property taxes and stays with the building if they sell it. And you get to subrogate it and get approval from the current mortgage holder. And this thing is really getting legs. We've only been at this for 6 months in Connecticut. We've already signed more deals than all of California has done in 3 years. And it's because of the technical underwriting that's going on. And there's enabling legislation here in North Carolina that hasn't really had flesh put out yet. And that's something we're hoping to work with some of the folks here in the room in the next few years. Power purchase agreements, we heard a little about that yesterday. Most people think of it traditionally for cogeneration, right? That's what it's been done for many, many years all around the country. Most recently for solar and wind, and very recently for combined heat and power, which again, Amory was talking a little bit about the other night. This is another game changer with what's going on now, the spark spread between electricity and gas, and the technology and the applications are just phenomenal. And putting that in a setting, we can create an islandable campus. So when there's a hurricane or a blizzard or snowstorm, which we've had, where I live in Connecticut, 6 major weather events in 2 years, including 2 100-year events in 2 years. And we've lost power for a week to 3 weeks over that period of time. Being able to run that campus, at least partially, you know, any of you have ever seen the facility manager from Princeton, there's a video he put together based on what happened during Sandy, and they stayed up and running the whole time. Fabulous when you get a chance to look at it. But we really see PPAs, performance contracting, and these grid resilient microgrids, this green resilience we call it, as really the future of campuses. I mean, we don't have time to get into this. You can read these when they get posted. But one of the problems, there was no technical underwriting for energy efficiency, and investors, you know, the Banks of America and TD Bank, who's here, and Wells Fargo, and SunTrust, all these other big banks, weren't really that interested in energy efficiency because there was no history to it. There's no precedent to it. You couldn't securitize those monetary assets. Well, now you can, right? And that's really a game changer because of this underwriting that's going on. There's technologies and protocols that are being followed, many of which have been used separately, but now they're being used together in a way that makes sense and is replicable, scalable, and sustainable over time. And that's really the key to this. You know, I talked a bit about PACE when we started. Like the Environmental Defense Fund started their own investor conference project, working with stakeholders around the country like us and others and major banks and building owners to define standards. You know, and it's such a simple thing, one would think, but it doesn't happen typically. Again, we review every major ESCO's proposals all the time, and they're all different. The way the methodology is put together for baseline and calculations and NV, it's always a little bit different. And EDF is trying to make this so that there is some standard everyone can follow, like plug and play for laptops and projectors. This is something that was brought up to us on this panel. You know, if you can, try to talk about what you think should be done to engage the students in these programs and processes and initiatives. And after hearing these students speak yesterday, I was sitting with Chris and Maggie Seelig, who's our Director of Quality Control based here in Charlotte. And I said, every project we do from now on here, we're going to get student groups and the faculty involved at the beginning and brainstorm with them. Because they can really teach us so much. I mean, we get to be mature people as we are today. And you tend to lose some of that spark of creativity because you've been beaten down over so many things over years. And we want to really be able to take that spark of creativity and the absolute wonderful ambition that these kids have and really use it to everybody's benefit. And help not just the STEM students, but the liberal arts students really like shadow the people working for the developers or the ESCOs or the consultants like us to see how these things really get done. So when they get out of school, they don't have these sort of, visions of wonder and, there's a reality that needs to be applied to these projects. And it can be done wonderfully, but it needs to be done in a way that everybody's learning constantly. One of the most important things is learning how to advocate for yourself and for your stakeholders. That's a fine art. Same thing with collaboration. And one thing is a real benefit I've seen is trying to get things that don't seem to fit together, learning how to fit them together in a way that everybody benefits. Not just one group, not just another group, not just the students, not just the faculty, but everybody on a campus must benefit from it. And as I found over time, some engineers and architects tend to think a lot of themselves. Not that anyone would agree with that here, but it's of non-technical people in many cases that drive these things and bring them home. And we need to appreciate that and not overlook those people in these situations. And I'm not going to have time to get into all of this, but we think that being able to take your campuses and create through the application of energy efficiency, renewable energy, and combined heat and power with really smart controls, like the other panels we're talking about, in a way that's elegant. We're not shutting things off and turning things on in a large way. Small incremental changes will build resilience to these campuses so they can become places of shelter over time. And campus is really the ideal spot for finish up real quickly. These are some pictures from some of our actual weather events, and these are in the neighborhoods we live in. And we're unfortunately going to see more of this, where we have utility trucks being delivered by the U.S. Air Force. Microgrids are a fantastic way to handle these situations over time. And hopefully one of these days I'll have a chance to talk some more about microgrids in detail. Here's an example. This is a project we're working on. It's the largest performance contract in the country, $200 million. And it's a central utility plant that's being built through a performance contract. And it's completely islandable. Started off at 20 megawatts, going to 55 megawatt plant that stays up and running during outages, which they tried and it worked on some of them before we got it going. We don't have time to get into the details of this. But within 30 seconds to 2 minutes, they can have most of this campus up and running. This is something we hopefully will come to North Carolina. The state is putting a little bit of seed money into a microgrid program, proving out the concept and showing it to everybody. We don't have time to get into this. And we talked about this the other day. I love this slide. Aggressive, passive. And that's it. Thank you.
Okay, next we have Greg Merritt with Cree Incorporated. Of course, imagine everybody in North Carolina knows Cree. So, glad to have Greg to talk with us. He's the Vice President of Lighting Marketing at Cree. Sort of a leading innovator. I think everybody, that's sort of a given. Supplier of energy efficient LEDs, chips, components, lighting products. He's been with Cree since '06. He's focused on marketing efforts with LED lighting and product marketing and advertising, so he knows where they're headed. So that may be some questions on where is Cree headed a little later, what's their newest stuff. Greg also serves as a member of the board of the Southeast Energy Efficiency Alliance and is a member of the board of advisors for the Center for Energy Development and Global Environment at Duke University. Prior to being with Cree, he was a long time with Nortel, also in North Carolina. He has an MS in Operations Research from University of California, Berkeley, and a BS in Systems Engineering from the University of Virginia. So, welcome, Greg.
Still awake, ready to go? Good, good. All right, I'm gonna try to get back some time, so we can get to the fun part, which is the questions. There we go. So Gary actually talked about how much the world's energy is used for lighting. It's a big number. Perhaps more closer to home for many of you, it's also a big part of your bill. As you can see here, a typical commercial entity, it's about a third of your electric bill. So that's a big number. We think we can cut that in a major way, and I'll show you in how. So where is the technology? You know, we heard earlier about incandescent light bulbs. We're all familiar with those. You know, should have been called heat bulb. I probably heard that too. Made significant advancements with compact fluorescence. You can see, you know, we've gone from 60 watts to 15 watts or less. This is the bottom of the slide is looking at if you have a room or a building that has 30 bulbs in it, what does it look like in terms of the electricity that's used, and what does it look like in terms of your annual operating cost, which is potentially as important. And you can see here we've taken the annual operating cost of 30 incandescent bulbs and cut it effectively by 90% by using LED bulbs. That's where the technology is today, but if you stay tuned for just a few minutes, I'm going to tell you a little bit about where we're going. So if we look at a few applications that are probably important to all of you, indoor troffers, indoor downlights, garage lighting, parking lighting outdoors, and street lights. We look at typical incumbent light sources. So this is a subject. Gary talked about earlier, right, the stuff that, has been around for many, many, many years. And again, I'm sure you'll find examples where your wattage is different than this, but this is just meant to be representative. And then we look at what was the first generation of LED lighting that was designed and brought to market to try to replace those. You can see that often a significant reduction in energy consumption, but the paybacks were longer. You heard a comment earlier, everybody's looking for a 2 to 3 year payback. But when you show up, especially in a commercial business, you say, well, hey, this is great technology, it's going to pay back in 5 years, and they go, get in line. Right? We got a lot of 5-year projects. So, LED lighting is based on semiconductors. All of you that have laptops and other things based on semiconductors know that as volume goes up and as you apply technology, you can drive increased performance. You can use performance in a couple of different ways. You can either use less energy for about the same cost, or you can use about the same energy for a lot less cost. Right? You can drive in both of those dimensions. So what we saw for these 4 applications is depending upon where the pressure point was. For instance, if you look at a downlight, we're already at 12 watts. So taking it to 6, which is technically possible, is that, you save an extra 6 watts, is that really the most effective use of the technology? Or should you cut the price in half? So you can see based on these 4 that we sort of tweaked where we applied either performance improvement or cost improvement in order to get the payback down. So you can see, we took troffers down to about 2.5 years, same with downlights, parking. Street lights were still a little longer, but you can see the great increase in energy efficiency. Well, why is that? Well, many institutions that buy street lights have a longer tolerance for payback. A city perhaps isn't looking at the same 18-month to 24-month payback because, let's say, they're not measuring their quarterly returns in the stock market. So again, where do you apply the technology? We then look at the current generation. So you can see, for instance, for troffers, we started at 52 watts at a price of X. We're now down at 32 watts at a price of about a little more than half of X. So we cut the price almost in half and cut the power not quite half. Downlights, for those of you that are real familiar with creating a downlight was our first product. So X back then was $100. To get from 65 watts to 12 watts cost you about $100. Made sense, and a lot of places didn't make sense everywhere. So the focus now is on getting that price down. So y'all can do that. Very smart. 29X means we're selling for $29 today. Energy hasn't gone down a whole lot, right? Another 3 watts, because that's not really the pressure. You're already saving 80% of the energy versus what's in the ceiling. So what you really need is to get the price down, so the payback time. And you can see similar progress in garage and street lights. So the message here is a couple of things. One is we're continuing to focus on driving the economics, making sure the energy consumption goes down, making sure the price goes down, so that the payback works for you, no matter what your model is for making that work. And the other message I'll give to you is if you looked at your lighting 6, 9 months ago and it didn't work, look again, because it changes pretty quickly. If we look at this generational thing, in some of these cases, generation to generation is 6 to 9 months. So it's not a generation that we think about. I think, where you call it old earlier. Oh, sorry. I think you just said we had a long history of the club. So we talked a lot about economics and saving energy, which is obviously important and one of our primary focuses, but there are other benefits to using solid state lighting. You can actually deliver better light in many cases than what you're replacing. You can get better clarity, better visibility, especially outdoor lighting. I'm sure Gary knows you replace a high pressure sodium with a solid state light source, you greatly improve visual acuity in that environment. That has a lot of benefits. One is you might be able to get away with less light, and you also might be able to make the people in that environment feel safer because they can see better. There's also improvements in the workplace itself, productivity, less fatigue, because you have better quality light source in place. Retail environments, right? Being able to show products, especially on lower shelves, with better illumination, better color rendition, very important for moving products. I think everybody's familiar with the maintenance argument, right? I'm sure there's probably not a person in this room that couldn't use your maintenance force to do something more productive than change your light bulb. I'm sure there's lots of other projects you have. So, you know, the economics are important, the energy consumption is important, but there are other benefits that shouldn't be silent. So what does this mean? These are some U.S. Department of Energy numbers here. I don't think I was meeting on it. Warren strongly enough to just get up here and do commercial about it. If you replace all the linear fluorescent fixtures just in this country, that's over 1 trillion BTU savings, 11 billion in energy cost. That's a big number. Let's look at it in a little more local sense. Well, if all of you have heard that the city of Los Angeles has just completed the first phase of their project to replace their street lighting with LEDs. It's over 140,000 fixtures. I think the economic and the energy story is compelling. But what's perhaps more compelling is if you look at these two pictures of the city and you look at the light pollution that was being emanated from their previous generation versus the solid state, and you come to the conclusion that the lighting is actually better on the right, on the street. It's more uniform and is effectively better lighting. 63% less energy consumption is the average over a 3-year project. That's notable for a couple reasons. I talked earlier about how the technology is changing. When they first scoped the project, they proved it in on 40% energy savings, and it ended up being 63%. They also proved it in about 7 years payback, and it ended up being less than 5. So, have faith. What's that mean for them? That's $10 million a year. You know, even for a city the size of Los Angeles, $10 million is a reasonable number. So here's my commercial side. You know, Cree is one of the early leaders in pioneering the LED technology that we see being used today. We are North Carolina born. We have about 2,500 people in Durham today. We are 100% committed only to LED lighting. So we're not doing any other kind of lighting. You know, I think you heard me say this morning, you can get better light, you can use less energy at lower cost. So what are you waiting for? Thank you.
So at Princeton, I saw him speak last year at NASEO, the National Association of State Energy Agencies. And it was a fabulous video that was made and put together by students who were so impressed with the facilities department that they were actually up and running during and after the storm. They had some of their friends and relatives that lived nearby were coming onto campus to take showers. Think about what that does for the university and the community that we were surrounded by. It took them a fair amount of time. I don't remember all the details, but it It took them a fair amount of time to get through all the different approval processes and so on. And because this is in New Jersey, where the electricity prices are probably almost double what they are in North Carolina, there's subsidies and tax incentives and renewable energy credits and so on for these kinds of things. It's a bit of a better business driver than what we have here currently. But here you have a much more common occurrence of storms like that. These are traditional. Now we don't know. People are saying they're going to skip North Carolina and just hit the Northeast. But we think that there's ways to get this done. I think the performance contract is probably one of the single best methods of delivery for a CHP, especially when it's islandable. There's a fair amount of investment required to truly make it an islandable asset. And a lot of electrical switching and controls and so on that need to get done. So, alternative financing is really one of the only ways to do it. Because as we know, none of you are getting much R&R money and more capital money out of Raleigh these days. So it's going to be hard to get the $5 to $20 million it will take to put in sort of a campus-wide microgrid system.
What's the outlook for LED lighting of athletic fields?
It will happen. The source efficacy is there. It's a matter of how much power you can put in a thermally managed system right now. Multiple manufacturers are working on delivering solid-state sports lighting systems. I know of European systems that are already being used in indoor applications for court-based venues. Not 70,000, 80,000 seat outdoor stadiums yet, but I would guess you'll see domestic solutions within the next couple of years. Whether or not they'll do everything you want, probably depends on how well they're engineered. The potential exists because the hours per year on those systems is comparatively small versus a roadway lighting application. The systems can be overdriven and still get the life needs that are important in that application space. So it'll happen, I would guess, in the next couple of years. You'll see product opportunities for that.
I mean, I'll add just a couple things to that. So just to his point, we already see smaller venues, soccer fields, tennis venues, and major stadiums are, I agree, probably a couple years away.
This is concerning LED light retrofits and classroom offices, things like that. We've run across the issue of understanding or right sizing or appropriately, getting the right lighting in, because we're looking at color, we're looking at typical things, color temperature and lumens, and they don't really seem to when you're comparing fluorescent to LED. Is there going to be some type of standard, some type of simpler way to be able to do this retrofit and know that you're kind of right sizing the LED lighting that you're putting into these spaces? Is there any kind of standard that may come out, or how do you do that?
I'll take a shot. There are a couple of things that I think are at the root of your question. One is, again, LED lighting is different light than what you get out of fluorescent, and the human eye reacts to it differently. That can be reflected in maybe needing fewer lumens than you did before. Perhaps also being able to space the lighting differently because of the optical control you have. There is some work underway in the IS right now. I believe the draft was approved on something called SP ratio, which takes a look at the various wavelength components of the light and allows you to apply factors, which says if you had this many lumens of this technology, you can use 0.8 lumens of this technology and get the same visual effect. That's a relatively new standard that hasn't, I would guess, been fully embraced or implemented around. But I would say most manufacturers should be able to provide you with an IS file which will allow you to do traditional lighting design using solid state products and get the effect that you're looking for. What we have seen a little bit is in the cases you do that, sometimes because of the visual acuity, you will perhaps think you're a little overlit, which is why we make it a dimmable.
I think fundamentally, there's two approaches. We see it in every lighting application space that there is. There's the functional equivalent approach, and then there's the engineered lighting approach. And we're firmly in the camp as a business of you should engineer the lighting regardless of what technology platform you use to deliver the lighting solution with. And so if you engineer the lighting and you have the IS files and you have the spectral properties, then you design the solution based on the technology you want to implement, and you don't take I have this, what's the functional equivalent of that approach? You engineer the solutions. As SP ratio goes, it really, SP ratio has leverage as a function of light levels. It's tied to scotopic and photopic vision, and the reality is that we all have lighting in the mesopic range, which is somewhere in between. And how much benefit you get from a source with higher SP ratio is a function of your seat brightness and whether or not there's really any benefit. So I think you should approach it from an engineered solution. It's worth it to pay for lighting consultants if you have to hire lighting consultants to do the job right. If you're Cree or GE, you may offer those services for free to your extent to do it based on volume. And we don't want to take business from qualified lighting consultants, but we think people should use them from our perspective.
Question for Clay with the housing controls with the plug-in cars. You mentioned how they measure it by the distance you travel to campus, but what if you're not taking the same route back? Is it able to be manually put in, saying you want to take a trip to the grocery store or do some trip to school or something like that? You have a last minute trip. How does that function to the recharging process?
Yeah, obviously, you're going to want to be able to override some of these automatic features, right? If I know that I'm going to have to drive, across the state to a football game or something like that, the user should be able to override any of the automatic functions. What I was really trying to demonstrate is that people talk a lot about smart charging of cars, and really what we're talking about is avoiding dumb charging, right? Dumb charging is when everyone comes home during the hottest part of the day, and they plug their car into their outlet, and they immediately create a very significant and large load at the worst possible time of the day. So we can do so much better than that. Cars like the Volt, cars like the Leaf already have the ability to delay charging. The user, as they configure the vehicle, can set up the time over which it should be charged. Some of the charging stations that you would put in, the level 2, potentially level 3, but level 2 chargers, which are higher voltage, in your garage, have timer selection so that you can keep from charging it at the wrong time. The user interface aspects of electric vehicles are really one of the more fascinating aspects there. But just having the ability for the battery management system, which knows how much is stored, and some indication of how much you would need to travel really opens up some great optimization. And this idea of actually knowing on the grid when there's excess capacity, the price of electricity actually goes negative. It goes negative in Europe all the time. Actually, Germany can't use enough of their wind, so they send it to Italy, and they actually have to pay to send it there. So it's when we have this information on the grid that we're really going to be able to level some of the intermittency, and it's really going to help the economics of clean energy greatly. Good question.
Good morning. Quick question for, I believe, Johnson, but I want to know what the next 2 years look like in development of your common building occupant, your average building occupant, interfacing with the BAS to control individual space temperatures, environmental conditions, things of that nature. What we see now, if what we see now is an indication of what's available on the market, it's fairly clunky and expensive to provide from what we see. And I see that as another opportunity to get occupants engaged effectively in controlling the building energy use. So can you guys talk about what the future of the next 2 years look like?
Yeah, sure. Hopefully the next 2 years will look a lot like 15 years ago. Let me explain. One of the pictures I didn't show in the day of the life is a system which we've actually installed in a number of facilities that provides individualized personal control. And what it is you know how in a modern car you've got your climate control, and then you've got the climate control for the passenger, and potentially the climate control for the back seat. Well, essentially the way this system works is it sits on a raised floor, and each of the desks is fitted with an individual environmental control system, which allows the occupant to basically set their own discharge temperature. So think of it as a mixing box. It has filtration. There are 2 diffusers on the desk, which you can adjust the direction. You can adjust the velocity of the air. It includes dimmable task lighting and has noise masking, so you can raise the amount of white noise, so it'll help protect some privacy. And the most important thing is that it has an occupancy sensor built into it. So when you aren't in your little cube, which you're not most of the time, because we know, right? So we can monitor everyone in the facility, 1,500 people. We know exactly when a workstation is occupied. And in fact, people are only in their workstations 40% or less of the time. So speaking to the ability to optimize the workspace layout, that really speaks to hoteling and things such as that. But going back to individualized control, this system is no harder to operate than the system in your car. Now, I built the first one of these in 1984. I made it out of plywood, and we were sure this was going to revolutionize the market. And that was a long time ago. So the interesting thing about our industry is that it takes almost forever or a little longer for some of these really good technology ideas to make their way in. Today you can buy raised floor systems which have thermostatic controls, and you can basically group a bunch of workstations together. There are some ways to directly address that, but if you don't design those into the very early stages of the design of the building, they rarely get designed in, and it's very hard to retrofit them. So that would be like the ultimate, and these are things that the industry's been doing for about 15 years. If you just talk about a user interface into the system, I don't know if Amory Loggins mentioned it, but we worked together on the Empire State Building, and every single major tenant in the Empire State Building has their own little portal, their own kiosk, if you will, that shows their individual energy use, and with sub-metering for lighting, HVAC, and plug loads. And what we've given the ability is for everyone to be able to manage and monitor their own energy use, and most significantly, compare their energy use with everyone else. So if you're a law firm on the 7th floor, you can compare your energy use per square foot or per hour with every other occupant in the Empire State Building. And with the click of a mouse or a click of an iPhone, you can make adjustments and track your changes. So I think, again, just like Ray Bradbury said, there's some great solutions in the marketplace that just need to be deployed quicker.
My question, building automation systems, we're talking more technology now, and automations and lighting controls. What's being done to make it easier to integrate all the different systems? Building automation overall hasn't done a good job of making the institutions that can't always specify the same vendor for every building. How's that being worked on?
Well, I don't want to dominate. Maybe you'll want to start with this and I'll pile on. Sure.
backnet native and Line and all of us. And a lot of the manufacturers have slowly been migrating towards using these open protocol systems, so that regardless of what your AE team specifies into, especially for new construction, it's the biggest issue. Regardless of what they specify into that design package, you can rely on, if it's done properly, almost plug-and-play technology with controls. Again, unfortunately, what happens in a lot of public construction, as many who have been victim of in this room, one of the first things to get value engineered, which is neither, right, out of the project is the controls, so the high-quality controls. And that is one of the features that really acts as a detriment to the campus for the existence of that control system for the next 10 to 20 years. So we see that the open protocols are making a big difference, but everyone has to be trained in what they are and what they mean. Controls companies need to be completely transparent in what they're providing, which has been a real uphill push in the past 10 years to get them to do that. So we all get to the point where people have as much interest in energy, even just 10% energy as they have in their phone apps, would make a big difference in the ability to do what Chris Martin brought up. That would revolutionize actually most everything we do. So training, I think, is a huge, huge part of this. So between the open protocols and training people on how it works, it really will make a huge difference.
We have one question up there at the top.
Well, we have 220,000 students at the University of North Carolina, and probably another, at least half that many in our private schools. What kind of skills can we be producing to feed this growth industry that you guys all represent?
From the standpoint of our, from the standpoint of the lighting business, I think there's key technology areas, optics, electronics, and thermal specialists are important to all these solid-state lighting solutions. If you dive a little deeper to the device level, obviously semiconductor physics and other things are important, but at the top level, electronic and computer systems are what power and control these systems. Optics are what give us the lighting, the lighting control behaviors, the reduced up light, the better utilization of light on the road. I also think that engineering schools have to start making sure that all technologists are systems engineers, not necessarily specialists. You can be a specialist, but you need to understand systems level thinking, and not just your technical specialty. I happen to have a kind of a multidisciplinary background that served me very well, kept me employed for a long time, but I'm valuable to the business because that's the level I work at, the systems engineering level, and I understand enough about the specialties that do it. So I would encourage that. I think most businesses are just now getting to the point where experts in sustainability and environmental metrics are important, because the market pull, at least in North America, hasn't mandated a strong focus on that. But forward-thinking businesses, need to start doing that. How do you close the loop on materials usage for your product? How do you make sure that what you're putting in the product is benign to start with? How do you make sure that your product is, that this generation is a better environmental solution than that generation? You're starting to see that, California, is obviously a leading indicator on those kinds of needs, but I believe that will grow from a business standpoint. And then lastly, financial specialists are important for the reasons that a lot of the panelists have said. I relate to it personally. I can't quite figure out how to finance a $25,000 solar PV retrofit I want to put on my house. But every system owner that buys this stuff is kind of confronted with the same scenario of how am I going to bundle it and bankroll it and ensure payback. So financial aspects of it are more important now than ever.
fact that in order for energy efficiency, sustainability type businesses to survive and prosper, they have to be approached as businesses, and not just causes, but businesses. And that brings in the financial aspects, the science and technology aspects. And I think students that leave your institutions aware of what's required to make this industry viable from a business perspective, and also take the active energy that they develop on campus out of their jobs is going to serve us all well.